Alright, we're doing changing the subject of the formula. And what it is some operations, and you have to do the opposite of the operation you see in order to get rid of certain terms, to leave one term or make one term the subject of the formula by leaving it on one side and everything else on the other side. It will normally follow this pattern here. You see a square root, that's the first thing you get rid of. Then you might encounter a fraction. Then you will encounter distributive law. To get rid of the fraction, you see you have to cross multiply. Distributive law, then you will have to factorize, then multiply or divide depending on the operation, then eventually square root. Now I solved this one over here. I'm going to put it back on this side to show you how it was solved. It was v is equal to the root of t over m. Okay, and we want to find for t. Now again, the first thing you see is the square root, and that's the first thing you get rid of by squaring both sides. So square both sides, sq, and you get v square is equal to the root of t over m square, and the square and the square root will cancel. I will show you how that is done in a moment. So what you have is v square is equal to t over m, and we need to get rid of the m, and it's a fraction. I said you will encounter fractions secondly, so we cross multiply. This becomes mv square is equal to t. Simple as that. How did the square root go away when you square both sides? X to the 1 over 2 is equal to the root of x. Remember that? So if you square x to the 1 over 2, then this will cancel with this because you have to multiply. Let me show you this way. X 1 over 2 times 2. It will cancel, and all that's left is x. So that's how it went. So that one is solved. We're going to solve these two at the bottom here. Good. So we're finding for v in r is equal to the cube root of 3v divided by 4m. So we're going to see what that looks like. Give me a second here. Right, we're going to see what that looks like. So the first thing, again, we have to get rid of the square root. We can't work with a square root, or in this case a cube root, so we have to cube both sides. So this would be r cube is equal to cube root 3v over 4 pi cube, and the cube cancel with the cube root, and we have r cube is equal to 3v over 4 pi. Good. And again you encounter a fraction, and again you will have to cross multiply. So here we're going to cross multiply. You have 4 pi is equal to 4 pi times r cube is equal to 3v, and we only want v, not 3v. So what should come after would be a multiplication. We have to take over division. We have to take over the 3 and it becomes division. So 4 pi r cubed divided by 3 is equal to v, and we got our answer. On this side, this one might be a little difficult, but all in all we can solve it. P is equal to mg plus mv squared divided by r, and again we're finding for v. I think we should change it up and find for m, because there are two m's. Let's find for v. We're going to find for m later. So what would be the first thing to do? Normally I said to you before that we will, whatever is connected by addition or subtraction, let's move that first, because that is not connected to v. So we can move this mg immediately. So let's put p minus mg is equal to mv squared divided by r. Good. And what's next? We have a fraction on this side. The r is connected but to mv squared by division, so we can move this r by cross multiplying. So let's cross multiply, and this becomes, put this over 1, this becomes r times p, everything on the other side, mg, is equal to mv squared. And this m now is connected to this v squared by multiplication. Note we move the division first. The denominator has to be moved first and then the numerator, whatever numerator is connected to the variable. So we need to take over the m, so when this m comes over, it becomes division. So rp minus mg is divided by m is equal to v squared. And we don't want the square over there, we only want v. So we're going to take over, how do we get rid of square? We square root both sides, or we take it over the equals, and it becomes square root of rp mg divided by m is equal to v. And again, that's our answer. Let's see another set of problem. So another set of problem. Let's see this one. This one will challenge you a bit, but we can solve it if we follow the procedure that was given. Alright, I think this one will encounter everything that I said down there, but let's see. So we have m, or d, over capital D over common D is equal to the root of f plus p divided by f minus p, and we're finding for f. So again, the first thing you get rid of is the square root, then fraction, then you'll have to do some distributive law, then you factorize, then you will have to multiply, I think, and then you'll have to square both sides. But let's see. Well, you will not have to square both sides here. But let's see, the first step is to get rid of, so we square both sides, and this becomes capital D over common D square, both sides is square, f plus p divided by f minus p, and this side is squared as well, so the square root goes. So what you have now is capital D square divided by common D square is equal to f plus p divided by f minus p. Good. We're encountering two fractions, so we have to cross multiply, and let's do such. So this becomes capital D squared times the one at the bottom here, f minus p, and common D squared times the one at the top, f plus p. And then we expand using the distributive law. This becomes, because we're finding for f, we have to expand to get the two f's. So when we expand here, we have d square f minus d square capital D p is equal to common D square f plus common D square p. Now we have to group them to factorize. So let's bring over our f, because we're finding for f, or common D square f. So this becomes capital D square f minus common D square f is equal to capital D square. We have to take over this capital D square p plus the common D square p. And now the common factor here is f, so we have to take out the f out of a bracket. P square common D square is equal to, yeah, you can take out this p if you like, 2 square plus square. Good. And this bracket is connected to this f via multiplication. F is left alone, and when you take this bracket over, it becomes division plus divided by capital D square common D square. And that is the end of the problem. We followed every single procedure there is to follow, and we got it done. So let's see a different type of problem. Now we're going to go on to quadratics. And perfect square is the first type of quadratic we're going to look at. When you see a bracket containing two elements that are different, I don't know how you think about it, but we know that x squared is equal to x times x. So if a bracket is squared, it must equal to that bracket times that very bracket. And we did this before. This is the product of two binomial expansions. So let's expand it and see what happens. So this becomes a, I'm going to use the method plus b, like this, a plus b, and this becomes a squared plus ab, plus this becomes ab plus b squared, and eventually this becomes a squared plus 2ab plus b squared. Now this is what perfect square will look like. Let me tell you how do you identify a perfect square. The first term is squared. The number, or can be squared, has a square base. The number and the letter is squared. And the last term has again a square base. If the number and the letter, if there is a letter. The middle will have the square base of A and the square base of B, and that 2 in front it. The number can be split so that a 2 can be there. When you multiply, you will see it again. But let's see it in this problem up here. Let's see it up here. This is x squared plus 6 plus 6x plus 9. Okay, question. What is the coefficient of x? It is 1. What is the square base of 1? 1 square is equal to 1. So 1 x squared, you don't have to put it 1, I put that. Then what I do, I leave the middle and I go to the end to make sure that the n has a square base, and the n has a square base of 3. The square root of 9 is 3. So 3 square is 9. Then I go to the center. If the middle number, remember we say 2 must always be there. If I put 2 there, 2, and I put back the first, the base of the first term, x, and I put the base of the last term, 3, will I get back 6x? Well, let's see. 2 times x is 2x, and 2x times 3 is 6x. So this is a perfect square because the two ends has square base and the center has a 2 that can multiply the bases and get back whatever was there. So what we do, it becomes x squared. So did I do it right? No, sorry. X plus the base of the two ends times the base of the two ends. So it becomes x plus 3 all square. That's how you solve perfect square. Let's come down to this one here. Let's come down to these and see if we can solve them. Okay, does the 2n has square base? This is 25p squared. This is 4q squared. Yes. 5 is the root of 25 and the p has a square. Again, forget about the middle. Come to the end. 2 is the base of 4 and the q is squared also. Square, square. Let's go to the middle. Is there a number? Remember, the 2 must always be there. Let's put our 2. The number 5, 2 5 is 10, and the 2 are the base for the back here, and 2 10 is 20, and we get back our 20 there. So it is a perfect square, but we have to put the entire base. So it's 5p times 2q, and when you multiply all this, you get minus 20pq. So we take our bases then. Alright, and we will see, well, let me show that 1 must be minus because of this negative here. So we'll allow this here to be minus the one at the back. So this becomes 5p minus 2q, and again 5p minus 2q. And when you solve, and we're going to solve this to see that we're going to get back this here. We're going to go in the opposite. So it becomes 5p minus 2q all square. And if we should, let me bring it down back here to show you why we put that negative there. 5p minus 2q times 5p minus 2q. If we didn't put a negative, we would not have gotten the minus 20 in the middle. So 5p times 5p give you 25p square. 2 times 5, okay, 5p times 2 will give you minus 10q, pq, qp, pq, same thing. And minus 2 times will give you minus 10 again, pq. And minus 2 times minus 2 will give you positive 4q square. And when you add the 2 up in the middle, you'll get back your minus 20 pq plus 4q. So that's why we put the negative in the center. Let's get on to this one up here, and then our final perfect square. Good. So, well, 16, I'm going to let you do this one at the bottom here, because I think you grasp the concept now. 16 has a base of 4x square. We don't know what that is, so let's leave that in the middle. Come back to the end. This is 8, so this will be 9 square. Then we have to put a 2. Then we put our 4x. Then we put our 9. And I'm pretty sure when you multiply all of this, 2 times 4 is 8. And 8 minus 8 times 9 will give you 72. So you don't have to worry about that. Then will be, and because of the minus, this 9 at the end will be more x minus 9. Our basis, 4x minus 9. 4x minus 9 all square. So you can do the one at the bottom. Note that the x is behind here, but it's the same concept. So we go on to difference of 2 square, and we're going to talk about why it is called difference of 2 square. Let's look at it, and then we'll see this here. X as a square minus difference. Difference, subtraction means difference, and then and the 2 squares will be the square of the x, and this 16 has a square base of 4. Everything that you look and you see that it has a square base and a subtraction sign. That's difference of 2 terms that have square bases. Difference of 2 squares. So this would be x. This is how you solved it. X minus the base is 4 square. This would be x minus 4 and x plus 4. If you do this, if you multiply this using the product of 2 binomial expansions, you will see will end up being x squared minus 16. You do that for verification. Again, the base here is 6x up there, minus the base is 1 square, 6x minus 1 and 6x plus 1. Alright, don't know why I put on all these different examples. I'm going to do this one. You can do this one at the back here. Base is 9. No, let me do the one at the back here. You can do this one here. What am I saying? Let me do this one. 3a square minus 2b square. 3a minus 2b. 3a plus 2b. Simple as that. 3 steps, nothing difficult at all. I want to show you that this is not difference of 2 squared, though it has square bases 3 and 2, and the cube is square. There's a plus sign there. The plus sign nullifies it. It is not difference of 2 squared. There must be a subtraction sign. It's this difference of 2 squared. Looking at it, 3q minus x. Many of you will say there's no square, number 1, and there's an x there with no square again, and then okay. Well, what we said initially is that whenever you have a term that you can add or subtract, you have to factorize. So if we take out what is common, which is x, you will have x squared minus 1. What do you have in there? X squared minus 1 is difference of 2 squared. So we solve the inside by leaving our x outside. This becomes x squared minus 1 square, and this will be x outside, square bracket, x minus 1, x plus 1. So yes, it is difference of 2 square. Now we're going to go on to quadratic expression. What is a quadratic? I'm glad you asked. This is the form it takes. A x squared, or whatever variable it will be, y squared, z squared, p, m, whatever variable it is, plus b x plus c, where a is the coefficient of the x squared variable, and b is the coefficient of x, and then c is just your constant term. How do we solve quadratic? There are many ways of solving it. It has a lot of application all over mathematics. So let's see how we will solve it. There's the factorization method, there is the formula method, and there is the completing the square method. Just give me a second, please. We're going to do first the factorization method of solving quadratics. So, how do we do that? What do we do? When our a is equal to 1 is the first thing we're going to do. When our a is equal to, when our a is equal to 1, we don't consider it because it wouldn't affect the b or the c. So our b is equal to 7 and our c is equal to 12. What we do, we need two factors, and this is the factorization method. We need two factors. When we multiply these factors, we will get what c is equal to. But when we add them, we will get what b is equal to. And those two factors are 4 and 3. 4 and 3. 4 times 3, 12, and 4 plus 3 is equal to 7. So then we replace b, or b here, with these two factors. It becomes x squared plus 4x plus 3x plus 12. And then we factorize by grouping as we did before. What is common here will be x. So we have x alone, not the square, plus 4. What is common here? 3. We have 3x plus 4. And